All right, let's have a quick look at some revision of hyperbolic conservation laws. This thing here is called hyperbolic conservation law. So this is really what we're talking about. It applies to gas flow in a pipe. Traffic flow is governed by hyperbolic conservation law. What this PDE says, it's a PDE and it's a bit muddled up at the moment. It's for rho and this thing called Q. What it says is if we've got some flow into an object or into a region, Q in, Q out, the difference in the flow between the flow in and the flow out must be equal to the change in density of the stuff which is flowing. That's what this says. Any change in density must be equal to the change in flow. So we've got to think about what flow means now. So flow, Q, which depends on space and time, is the product of density of stuff times by the speed that the stuff is moving. This isn't our information speed, by the way. It isn't a wave speed. This is the speed of the particles of stuff or the elements of stuff. So the obvious example is stuff is cars, right? So if you're considering a traffic flow problem, U is the speed of each individual car, rho is the traffic density, and Q is the traffic flow. Obviously, we want a PDE for density alone, right? So we want to simplify this PDE, get rid of the Q, and obtain U only. We want to obtain an expression for rho only. A common assumption is this is known, right? We know the speed of the individual elements, and then it's a simple substitution job. We just have to plug Q equals rho U into QX. We've got to differentiate this with respect to X. It's two functions, so we're going to have to use a product rule, and we're going to obtain, once it's all said and done, we're going to obtain the following. Now, this C, it's a wave speed, and it can be quite complicated, and it often depends on density. But it depends on what U looks like. For cars and traffic flow problems, the speed at which, information like braking, if the car in front of you brakes, you've got to brake, the car behind you's got to brake, and so on, right? So that braking wave, that wave of brakes propagating backwards, that's that moves at speed c. So hopefully that's a quick revision on the hyperbolic conservation law and how it can be applied to traffic modeling.